Hi everyone, this is Keshav Giri, application engineer for Miraculous Design, and today we're going to be looking at Neoverse N2 processor models using VisualSim Architect. Specifically, the usage of Neoverse N2 clusters in a CMN Mesh network. So first, let us take a look at the model snapshot. So this is a 2-die architecture with UCIe interconnects between the dies. And on each die, we have two Neoverse N2 cluster cores connected to an XP network, the CMN Mesh. And on each die, we have a system level cache in the form of an HNF and a memory device. And this is what the model is going to look like on VisualSim Architect. So we can see that on each core cluster, we have 4 cores as per the configuration. And all the cores are going to run at the core speed megahertz specified as a top level parameter. On start of the simulation, each core cluster is going to start executing a task trace, and each of the cores present in that cluster is going to be triggered in order. And at the end of the simulation, we are going to be looking at the latency for the task completion for all the cores present in a core cluster. So we have the L4 cache slice and DDR memory present on each die. We have a global system address map that is configured to evenly split the overall address range between both L4 cache slices, the HNF devices. If there is an L4 cache miss, it is going to be rerouted to the DDR memory present on the same die. And as mentioned before, the software traces run on each cluster and the cores in that cluster are triggered in order. The final latency for all the cores present in the cluster to complete is plotted on a graph. Now, let us take a look at the statistics and the output of this model. We are calculating the power consumption per die for this architecture. So we will be able to see the instantaneous and average power consumption for each die on the power plot. So we can see here the instantaneous spikes and drops and the average power consumption for die 1 and die 2. We can also see the latency for the task completion for each flow, where flow 1 corresponds to the cluster core cluster 1 completing the task trace on each of the cores present in that cluster. So we have the task completion latency for each of the core clusters. And for all the components present in the system, we'll be able to see latency statistics. For the cache and memory devices, we'll be able to see the number of read requests, write requests. For the caches, we'll be able to see the hit ratio and the miss ratio. And for the CMN mesh, we'll be able to see end-to-end latency statistics, network latency statistics, and buffer occupancy statistics. So to show you how you can perform trade-off analysis using VisualSim in a very easy manner, we run 2 configurations of this model with the cores running at 1200 megahertz and the cores running at 1600 megahertz to perform a quick comparison to see how the final statistics vary. And from the results of these 2 configurations, we can see that the overall trace completion latency is lower when the cores are run at a higher frequency at 1600 megahertz versus running them at 1200 megahertz. So that has been a quick overview of how Neoverse N2 clusters are used in models in VisualSim and how you can quickly perform trade-off analysis using these models in VisualSim. Thank you.